Welcome everyone to the third coding workshop of the Rust on Linera Spring Hackathon. I'm here with Christos, who is the software engineer at Linera, who's going to be conducting the coding workshop. This will be the last workshop for the hackathon. Submissions are due on June 16th. If you guys have any questions, feel free to email me. You should be able to find it on my username there. But with that being said, I'll pass the mic over to Christos, and then we'll share the recording.
Hey everyone. As per usual, we've pre-recorded the workshop just to make sure that things go off without a hitch. The third workshop is building on the first two. It's about composing applications, so how you can call one application from another application. It's about 20 minutes long. Yeah, not much to add. Hope you guys enjoy. Hello and welcome everyone to the third workshop of the Linera Spring Hackathon. My name is Christos. I'm a software engineer at Linera. And today what we're going to be doing is we're going to be looking at how one application can call another application on Linera. Specifically, we're going to be doing this by building a so-called Meta-Fungible application, which can call into the fungible application we built in the previous workshops. So yeah, let's get started. The first thing we want to do is we want to build our Meta-Fungible application project. So we're going to be using the project new command, Linera project new, and let's call it my Meta-Fungible. Okay, I'm going to cd into my Meta-Fungible, and we're going to run cargo check just to make sure that everything compiles. Can you give this a second? Okay, looks like everything compiled fine. So let's open this up in our IDE of choice really quick. So I'm just going to open an instance of Rust Rover real quick. Cool. And we are going to head over, as per usual, to librs. Okay, so what we want to do is, first of all, we are going to create the operation. Well, actually, no. Let's start by adding our fungible application to the cargo toml, because we're going to be using the operations from that application. So we're going to add the fungible application here. Fungible equals, and then we're going to be referencing it by path. Path equals my fungible, and that's how we can import the other application source. We're going to cargo check again to make sure everything compiles. What happened there? Okay, I think we might need to name it my fungible. Yeah, there we go. Okay, perfect. So now we've imported my fungible as a dependency, so now we can use the operations exported by my fungible in our Meta-Fungible application. So let's head over to librs, and the first thing is our operation type here is going to be of type my fungible operation. So that should be exported. I don't know if my IDE is not picking it up, but yeah, cargo seems happy. And if we jump to definition, it'll jump me over to the my fungible project. Cool. So let's head over to the contract, and we have all of the boilerplate set up by the project new command. And the first thing we want to do is we want to give some parameters to the Meta-Fungible application. Specifically, we want to tell the Meta-Fungible application which instance of the fungible application it should point to. So we're going to do this by supplying the parameters here, an application ID, which is generic over a Linera application. But in our case, it's going to be generic over fungible, because it's my fungible application API. Perfect. So it's going to use the application binary interface of the Meta-Fungible application. Perfect. There isn't much to be done here in terms of there's no instantiation logic. All we have is execute operation logic, which is going to be very similar to the fungible application in a sense. So what we're going to do here is we're going to match on the incoming operation. Match operation. And we just have one variant, the transfer variant, which we're going to destructure here. So we have owner, amount, and target account. And what we're going to do is we are going to use the method self.runtime.call application to call the application, to call the fungible application. We're going to authenticate the call because we need that so that we don't transfer funds for which we don't have the rights. So we're just going to put true here. We're going to give it a fungible ID, which we haven't defined yet. Get that to in a second. And then we're going to reference, we're going to call the application, with the operation here, like so. Okay, cool. So we haven't defined operation or, well, operation is defined here, I guess, but we haven't defined the fungible ID here. So let's do that quickly. Let fungible ID equals self.fungible ID. Which is going to be a method we're going to write right now, which is going to get the fungible ID from the application parameters. So to do that, we're just going to head up above here, and we're going to import application contract function fungible ID. It's a immutable reference to self, and it's going to return an application ID of type my fungible application API, and we're going to use the self runtime again here to get the application parameters, where the application parameters, as we defined here, are an application are basically the application ID. So let's see if this compiles first of all. So cargo check. Okay, everything seems fine. Actually, I don't think we need to destructure this here, if I'm being honest, so we can just use this. And in fact, we don't need to match on the operation at all. I think we can simplify this here by just taking this outside of the match and using the operation in line like so. Okay, perfect. So that's the contract part of the Meta-Fungible application done. All we're doing is we're using the contract's runtime to call the application with authentication by pointing to the application ID we're going to provide to the Meta-Fungible application when it's being deployed, and we're just passing the operation because, again, remember, it's using the same operation back here in the application's API. Okay, so that's the contract done. Now let's head over to the service. And in the service, we're going to do something very, very similar to what we did with the fungible application, in that it's going to be GraphQL in, GraphQL out. And to do that, we're going to head back into librs, and the query type is going to be of type request, async GraphQL request, and the response is going to be of type async GraphQL response. Now this won't compile because the service hasn't been updated to reflect these types, or it shouldn't compile. All right, I mean, yeah, it's all generic anyway, so this is fine. But what we want to do is we want to, similar to what we did with the fungible application, is we want to create a schema from our operation and then execute the query against that schema. So let schema equals schema. We're going to take the state and clone it. We're going to take the Meta-Fungible operation and use the mutation loops from that operation. So we need to import that quickly. And empty subscription, because the Meta-Fungible application does not support any subscriptions. And then we're going to do schema.execute query. And then again, because this is asynchronous, we're just going to await this. So I don't think this is going to work if we cargo check. And it's not going to work because state isn't clone, because we need to wrap everything in concurrency primitives, namely arc and mutex. So we're going to do that really quick. We're going to import arc. Here. And then this is also in mutex because it is mutable. And we need to wrap them here real quick. So I don't know if arc can. Yeah, I don't know if we can do into here, but let's just keep things simple and just do arc new state, and then here arc new mutex new state. Oh, sorry, not state, because it's the runtime. Okay, let's cargo check. We haven't imported the schema type, so let's just import that quickly here. And right, we would bring my ID imported the wrong version of schema accidentally. Okay, cool. So that seems to work. We can allow and use here to stop the compiler from complaining and head back into contract to remove the operation type here. Okay, cool. So everything compiles, and we're ready to try out our Meta-Fungible application. So to try out our Meta-Fungible application, we're going to do two things. First, let's create a wallet quickly against the DevNet if you don't have one already. So I'm just going to quickly head over to linera.dev, getting started, hello Linera, where there's the command here, Linera wallet init with new chain that you can just copy paste to initialize your wallet from the DevNet faucet. So we're just going to initialize the wallet quickly, Linera sync balance, and we have a balance of 99.999 tokens. Perfect. So our wallet's initialized, and the first thing we want to do is we want to deploy the Meta-Fungible application first, because Meta-Fungible is going to depend on Meta-Fungible. It's going to reference that application ID. So to do that, we're going to head into Meta-Fungible. We're going to do Linera project publish and create, and again specify the JSON argument, which is, I don't know, 1,000 tokens or however many we want the fungible application to start off with. So it's going to build that quickly, publish the bytecode, and then instantiate the application against that bytecode. Perfect. So that's done. I'm going to copy this quickly just so that we have a reference to it. And in fact, I'm going to create a new terminal here because I think we'll need that later. Now let's head back into my Meta-Fungible. And here we're going to do something slightly different. We don't have arguments, but we do have parameters. Again, the difference between arguments and parameters is that arguments are provided only to the chain that created the application, whereas parameters are variables which are available in every chain that runs the application. So let's do Linera project publish and create. And then I don't remember what the parameter argument is, so it's JSON parameters plural, okay? And dash dash JSON parameters. And here we need to put single quotes and then double quotes, because this is again this is JSON, or I guess actually we can do the same thing we did for the amount here, I think. And in here we can put the application ID of our fungible application. So let's deploy that. Okay, so it's compiling, publishing the bytecode, creating the application against that bytecode, and we're done. We have an application ID for the Meta-Fungible application, and let's just note down quickly that this ends in 105. Okay, let's start a node service as per usual. So we have a GraphQL ID. Okay, perfect. And let's get a link to the fungible application. So to do that, we're going to be using the applications field. Let's get the chain ID here. And we're just going to ask for the link. And we want the one ending in 105, so we're going to take this link. And now we have the GraphQL ID for the Meta-Fungible application. So looking at our mutation route, we have the transfer operation. And we can do mutation, transfer, and we're going to transfer from ourselves. So the owner here, let me just do this quickly. The owner is this guy, 1F6. The amount is, let's say we want to transfer 50 tokens, and the target account is, we're going to send it to a non-existent account just so we can see to a non-existent owner, just so we can see the actual balances change, and we don't just get the same number for demonstration purposes. So chain ID, we'll send it to the same chain, so our chain, and the owner will just use the same owner here, but we'll change one character at the end. It needs to be hexadecimal, so this won't parse anything, but if we change the F to an E, for example, this should work. Okay, cool. And the operation was successful because we get back a certificate hash here. Now, if we head back to the node service tab, we can take this link, which is the fungible application, and we can write a query. First of all, to get the accounts and the keys of the accounts. So here we have two keys in our accounts, because we have the original one, the one that ends in F, which is the account corresponding to our owner on this chain, and then there's this new account, which is the account corresponding to some other owner, which doesn't really exist on this chain. So now if we get the entry, I think it's the entry, no, entries, I think. No, it's the entry. For the key that ends in F, we should see a value of 950. There we go. And if we get the one that ends in E, we should see the one that we sent the tokens to, we should see a value of 50. Perfect. So that's our Meta-Fungible demo done. We saw how you can compose applications in Linera. We use the source code of the fungible application and the Meta-Fungible application using the types that we defined in the fungible application. And the Meta-Fungible application, of course, they have to be public. We did this anyway when we built the fungible application, but they do have to be public so that they can be imported into the Meta-Fungible application. And yeah, thank you very much for watching, and have fun building apps on Linera.
Perfect. That's the coding workshop for today. If you guys have any questions, Christos and I will be here for the next 5 minutes or so, just to answer any questions that you guys might have. So yeah, you can write them in the comments now. You can ask questions about the hackathon, about the coding workshop. We're open to either. Submissions are due on June 16th. We've got the 3 tracks right now. We also just released a new example application for something called Hex, which is a gaming application. So if you guys are interested in participating in the gaming track, there's now an example application that should be a good walkthrough to show you guys how to actually build something there. Okay, if that's all the questions, then we'll end here. We'll be posting this up on YouTube in a moment. Um, Interesting. Hi guys. Tristan in the main chat was curious about what it takes to become a core dev with Linera. Can you speak to this, Christos?
Yeah, I mean, it depends what we mean by core dev. I think the easiest way is probably to go on GitHub and find open issues and start addressing them after communicating, I guess, asynchronously on the issue with the team. Also, we're reachable on Discord and Discourse, just so that you know, we don't want people working on things that are not gonna, that aren't immediately part of the roadmap. Now, if you're talking more about joining like the core team, that's a different question and not one that's up to me. But I think we are hiring right now. So I don't know, Jesse. We'll have to share the job postings if there are any. I'm not entirely sure right now if there are, but if there are, we will share them.
I think we're always hiring Rust developers. Um,
Right.
and yeah, Christos made a good point. The GitHub repository for Linera is totally open source, and all the issues are posted there. So anyone can just kind of jump in. And I think that um, if someone is able to just jump in and contribute code right off the bat, then I think that that's a very good signal that they would be a great dev for the core team.
Mhm.
Um, yeah, and I think there's a job posting. Let me find it here. It's also in the I think the Discord chat.
Mm.
Yeah, software engineer, Rust, remote. You can also send them that link.
Mhm.
Okay, perfect. Um, we'll end it there. Thank you, everybody. We'll post this up on YouTube and we'll talk to you guys later. See you guys.
Yes.